guys is actually go through this bonus problem because we did not get a chance to do that before the quiz. So let's go ahead and make sure we can do this. All right. So the first thing that I want to do is make sure that this is working. There we go. Okay. So what happens is you have two unknowns with this question. You do not know the mean, turn the lamp on, please, and you do not know the standard deviation. Okay? So since you do not know both of those things, you're actually going to have two equations. So if you have two things that you do not know, you're going to have two equations to solve it. If there were three things you did not know, you'd have to have three equations. So in Algebra 2, I know that you've done some solving for, say, x, y, and z, and you had to have three equations for that. Okay? All right. So therefore, we need to figure out where we're going to get our two equations from. So the first one, first of all, this is a problem about the months, the age of the children, the age of the babies in months before they walk. And so what we do not know is what's the average, and we also do not know what's the size of this standard deviation. How varied is the data? Okay, so we're just going to kind of get ourselves a picture going there. The first information that we got is that 5% of babies have learned to walk by the age of 10 months. Okay, so somewhere in there, I'm going to be putting a line, and that's going to represent 10 months. And what's below that 10 months? 5%, because it's in the 5th percentile. Sorry, 5% of other babies. 5% of the babies. Okay. All right, now, 75% of the babies are walking around the age of 13. I'm going to put that about right here. So, 13 months is above 75%. So everything below it incorporates 75%. Okay, so 75% there. All right. So in order to come up with our two equations, we need to get that from both of these locations. We need to get an equation from this location, and we need to get an equation from this location. So I need to know more information than just the data. This right here represents the context. That's the x value in our equation. So 10 months in this equation is our context, x. 13 months in this equation is our context number, letter for x. So what else can I get in these pictures? What else can I get for these equations based on the information? Good. You can get a z-score. So let's do that because I know the percent below them. Okay? So, to get the z-score for this one, I'm going to do inverse norm of that percent below of 0.05. That comes out to negative 1.645. Okay, good. So the z-score for that placement is negative 1.645. And so let's do the z-score for this spot right here. The z-score for 13 months is above 75%. Now, do you remember, that's Q3, so you should remember that from a few days ago. Do you remember that? 0.6745, okay? 0.6745 is our z-score there. So, from that, we can make our two equations, and here's what that looks like. So, our equation for this data in blue is going to be this. Negative 1.645 equals our data minus the mean over the standard deviation. Okay? So data minus the mean over the standard deviation. Okay. So now our formula for this red equation is going to be 0.6745 equals our data minus the mean over the standard deviation. Okay, and you know, I actually had quite a few people be able to get to that point right there. They were able those equations, and that's good, because you actually then got the statistical aspect of this, but the bad side is that the part you missed is Algebra 1. Okay? So, the reason that may have happened is because these kind of look different than they did in Algebra 1. In Algebra 1, you mostly had x's and y's, and it's kind of a range. It's got some fraction stuff going on there. So let's see if we can't fix this so it looks more like something you did do in Algebra 1. How can I unfractionize this? So get rid of the fraction by. Multiply by the standard deviation on both sides will allow that to cancel, and it'll make this equation here, negative 1.645 standard deviations equals 10 minus the mean. Alright, let's do the same thing over here. Multiply by your standard deviation. So that makes this equation point, and I'm actually going to write it underneath of this problem because I'm going to, that's the format I'm going to use it in, 0.6745 standard deviations is 13 minus the mean. Okay, so now that it's at this point, it is a system of equations. This is something that you learned to do either substitution, elimination, or to solve by graphing. I think it would be awkward to solve this by graphing because you'd have to change x's and y's, and then you'd kind of have some weird slopes and such. So let's not do that. How about we solve, because of this happening right here, I chose, what method do you think I chose? Good, I chose the elimination method. Okay, so we're going to do that. In order to do that and make those mu's opposite, I need to change the signs of one of those lines. So I did that. I'm going to change the sign of this red line, make these two negative and this one positive. So when I combine, I get negative 2.319 sigma equals, and 10 and a negative 13 is negative 3. And again, a negative mu and a positive mu cancel. So I divide, and I come up with the standard deviation being 1.29 months. So there we go. So up here in my picture, that means this distance right here is 1.29 months, and going down here is 1.29 months. So in essence, I could say that 68% of the babies are contained within about 2.5 months. Within a span of about 2.5 months, 68% of the babies are learning how to walk, because I just kind of added that total distance, and that's 68%. All right, let's finish this out. How are you going to finish it out to get the mean? Okay, pick one of these things and substitute it in. So I'm going to go 0.6745 times 1.29 equals 13 minus the mu. And when you solve that, you get 12.12 months. All right, so that's saying the average age that babies are walking is around 12 months. And the standard deviation is 1.2 months. 1.29. Okay. So, there you go. I actually, with my boys, I had one here at 10 months and one, let's see what this is. This is 12, and that's like 13.3. Actually, it's probably closer to 12.12 plus 1.29. About 13.5. 14.8. What's that going to take me up to about right here? 16.1. Aha! Woohoo! Mine's about 16 months, so he's within 3 standard deviations, but barely. So that is a big difference in my boys walking. One at 10 months, one at about 16 months. So there you go. We were kind of getting worried with this one. We were like waiting around, but I don't think it really means anything. If anything, I think he might get smarter of the two, so there you go. Okay, so now that is finished, what I want you to do is take a look at your number 8 that you did on the review. If you were comfortable with that and you got that correct, you got a standard deviation of 0.669 inches and a mean of, I don't remember what it was, 10.23 something inches. So you ended up getting answer C. Okay? Now, you need to keep in mind that your test question about this will not be multiple choice. So you cannot just plug in the answers and get the thing. You have to know how to work this. So as I come around and stamp you, I want you to be working this one if you weren't sure how to do that before. If you were good, then you can. Okay, so let's actually look at that number 8. Let's see how you did the work on that. So here's how that looked. Okay. So, and I'm just going to sit here and kind of go through some things instead of stand up and point. I think probably, so you had your inverse norm of 0.20. And so here was your equation. Here was one of your equations. Here was the other equation. I did have some people mess up on this inverse norm. It's inverse norm of 0.70 because 30% are above that, so that means 70% is below it. Okay, so I rewrote the equations by multiplying, and then I changed the sign for this second one so that I could eliminate. So I ended up with this standard deviation. I went and plugged it in and got that mean, so that rounded to the values in C. Okay, any questions on that? You need to get that process, and what I'll do is I'll send you a text Sunday that has a link to a few more problems because I got to make them up so that you could practice that if you wanted to, because you will have one of those on your test. Okay, as a free response. So here we go. Let's go through the rest of those answers real quick. So here's your percentages. That's your 68, 95, 99.7% rule. Okay. Number 2, if you want to compare two things, you need to compare their z-scores. So here, this girl did better on test A because it's more standard deviations above the average. Okay. Now number 3 is seeing if you know the language of statistics, that you know that this number 1.2 means 1.2 standard deviations above the mean, and negative 2.3 means 2.3 standard deviations below the mean. Okay, so that's the language. Now, I like this number 4. It's a neat way to think. If I was, say, the sponsor for a math team and we went to some competitions, like if you're thinking going to the ACT Deck, I know is going tomorrow, to a contest. So suppose that this year my students averaged 40 on this particular math test, and last year they averaged 35. So I might be thinking, hey, you did a great job, I got a smarter team this year, or something along those lines, okay? But in actuality, this year, since the average on this year's test is 38 and the average on last year's test is 34, technically this year's test was probably just easier than last year's test. Both of the z-scores are the same. Okay, so here's a question. If my math team scored 1 standard deviation above the mean, what percentile are they ranked in? '84, very good. 84, because you know that the mean is at the 50 and 1 standard deviation up, there's 34% in this. So therefore, they are in the 84th percentile. Good. Okay. So they did equally well on both exams. All right. Number 5, the reason for that is to see if you know that mean is affected by adding and multiplying, while standard deviation is only affected by multiplication. Okay? All right. Now, this next one, strangely enough, I struggled with this one because I kind of don't have any common sense, and I remember the first time I did this, I couldn't figure it out, and then I thought, oh, okay. So here's what's happening. Because you know that the shape is approximately normal, it's going to be somewhat symmetric, and 99.7% most of the data will be contained within 3 standard deviations. Okay? 99.7. So that means from the bottom to the top, how many standard deviations will it span? From the bottom to the top, how many standard deviations? 6. So you have 3 down and 3 up. Okay? So it says that the minimum is 18. So from 18 up to 54, there should be 6 standard deviations. So that from here to here is a range of 36 points. And if 36 points is the span across 6 standard deviations, then that means each standard deviation's got to be about 6. Because 36 divided by 6 is 6. Alright. So, I struggled with that because I don't have common sense, and that actually just kind of naturally falls from the design of the normal curve. Here's a fact. A standard normal curve has a mean of 0, standard deviation of 1. That's why if you have one of those calculators that has the extra things that come up in the menu, I'm always having you put 0 for the mean and 1 for the standard deviation. Alright, we did number 8 already. And 9 is a transformation from inches into feet. So that's division by 12. And division affects both the mean and the standard deviation. So that's why you divided both the mean and the standard deviation to get B. Alright, so that's kind of midway point. Any questions so far on those? Any questions so far? We're good? Yes. Correct. Well, probably not, since it's approximately normal shaped. That right there implies the standard deviations that it's kind of encompassing, as well as the symmetry of it. Well, what is this? Is this close? Yeah. What's the 50% location? 32? Oh, it's at 36. Really? So it's a little skewed to the left. Yeah, because the mean is less than where the median would be if it was symmetrical. Okay. Well, I think that you can only go with this idea, and it stems from that approximately normal shape. I mean, otherwise, I don't think that you have anything to go off of. So that's the intent, I guess. Although I see, so you're trying to say we need more information. I mean, technically, yeah. Technically, to make a really, especially if that's not really the middle. So I think it's debatable based on what you have. So there you go. Probably if I was to give you that and I wanted you to answer one answer on the test, I wouldn't give you that kind of generic free, open option there at the end. Okay. Yeah, we did 9. Number 10, as I went around, these are the ones that I saw the least work on. If you're going to do these problems, do not just say, oh, I just did it in my calculator. No. This is actually a requirement to include on the AP test. You need to include this Z-score setup so that you can then come up with your answer. And go ahead and put these in percents, because that's what a proportion amount is. It's asking for this percentile area. This one was the dollars. Now, I did say in the past, I said you could put it in terms of decimal or percent, and that's true. I've said that. Now, from the teaching standpoint, I have noticed that students are struggling with, they'll look at this 0.5814, and they'll not know if they'll think, oh, that's 58.14%. Okay? So I want you to keep straight that a Z-score is not a percent. It's this end area that's your percent. So I think if I make you start going ahead and putting those percents in when it's a percent, you might be better off keeping that straight. Okay, D is between two z-scores, and that ended up being 37.7%. E is wanting to know the location with 20% below it, and it wants it in money terms, so therefore you got the z-score, and then you had to turn it into context, so that means you're looking for x. See, the x in context is the x in your problem here, so if you want the context, then you are looking for the x in the equation. Okay, for this number 11, I drew a picture and I actually flipped the values. This is a picture of population 1, and this is the picture of population 2. Because in the information up here, they have the same mean. Okay, so you can see that they're kind of located, stacked on top of each other with about the same mean. And then it says that the standard deviation of the first one, so the standard deviation of P1 is twice that. So look at this, P1. Do you see how it's more spread out? So it's wider. Okay. But here's the deal. If I say, what percent is within 2 standard deviations, that remains the same on every single normally shaped curve. 95% is what is contained in 2 standard deviations, regardless of how spread out the values are. Regardless of how spread out the standard deviations are. Now, what's going to be different about those two curves? What's going to be different? The mean's the same, but what's the different locations in standard deviations different? The what? The spread is different. It tells us that. How about this? Okay, how about this? If you knew in context what value this is, so you could say 95% of the data is between these two values here. But on this population 1, 95% of the data is between these two values here, which are larger or more spread out numbers. Okay, if you're on the same scale. Alright, so that's what you'd be able to tell. Okay, number 12 is another one where you had to find the z-score, and then you had to find the area above it, which is 25.85%. Number 13, once again, it's finding the area below, so that's the inverse norm of 0.29. You need to be showing this. I know on multiple choice you won't actually have to show this, but on a free response, definitely. And so that came out to be 39. Hey, watch your labels. This problem is about decibels. So that value is at 39.31 decibels. So kind of what I did was at the end of the page, I looked back to see if my labels were on all the things. Here, this guy, he said 18% of the people would have to live to 120. That's this upper 18%. So therefore, to identify this z-score, I had to do inverse norm of the lower 82%. There's my z-score. I put it into the equation, and the standard deviation is 21.85 years. Okay, next. Oh, I'm going to tell you that this number 15, if you missed it, then you might have missed it because you did a careless little decimal changing incorrectly. And I have not completely decided which all problems I want on the test because I pull from various resources, but I remember one of the tests that I used in the past, which I could be pulling from, had one of these kinds of problems where students made a careless mistake with their decimals. So let's take a look at that really quickly. So this machine is set up so that 8 ounces, an 8-ounce cup, will only overflow 0.5%. That's a half of a percent. So that is in decimal form 0.005, which means that your down here is 0.995, not 0.95. So here's this. If you got a different z-score on this problem, then you got the wrong answer. Okay? And maybe you got a wrong z-score because you moved the decimals incorrectly. All right. Oh, here's this problem starting about the pygmies. Do you know the pygmies are an actual group of people and they have particular characteristics? They actually are shorter. They live in Africa in different areas. This is from Zaire around the Congo. So here's, you know, a European or an American person, and here are the pygmies. Now there are some children in here. These are the shorter ones here. But so these guys here are the adult pygmies. It's not like this is a bunch of 8-year-olds or something, okay? So according to this, the average size of the pygmy is 51 inches. So I transferred it into inches. So if they are making their opening just 4 feet high, which I'm not quite sure, why would they make the opening shorter than the average? Maybe it uses less materials, and so it would be, you know, easier to make. Maybe because of predators, they want that to be lower. I don't know. So, how many of the pygmy population, what percent of the pygmy population will have to duck to enter? That means that they are in this yellow section because they are taller than the door. So you had to find the z-score for that door, and then find the area above it, which is 93.32%. So a lot of those pygmies are going to have to duck going into that hut. Okay, so next, here's kind of a made-up problem about their Molino ceremony. Maybe they want everybody to fit the part, so they want them to all be up close in height. Right here, this section right here is the heights that are allowed. This yellow section are the ones that can be in the choir. So the part that's in black are the sizes of the pygmies that cannot be in the choir. Okay? I will tell you that when I did this review, because I do my reviews, you know, a lot of times I'll look back and redo some of them each year. When I did mine this morning, I actually did this a different way than I had in the past. In the past, I had actually computed this area and added it to this area. So you can compute those two separately and add them. Or what I did today was I decided to determine this section here and then subtract it from one, and then that would give me the rest, the black section of the pygmies that are left out of the choir. How many of y'all did the subtracting? You guys did the subtracting method? How many of y'all that did those added? Choose the adding one? Okay. All right. Here we go. And then this is, if you are 53.5 inches tall as a pygmy, you are in the top 10%. All right. This number 17 should look familiar. Hey, I actually really like this problem because I could see a lead, you know, maybe a manager or a lead person in a company that has a group of employees that are doing some things, and the mechanical managers or whatever are having these qualities impressed upon them. So let's talk about this. So this was about a manufacturing process and having to do with removing the chemicals. So what happened was, what percent of the batches of water discharged exceeded this much standard, okay? So at first, they were having the amount that exceeded that much discharge at a high 11.7%. Okay, so as the lead of this company, I'm not comfortable with that much discharge. Maybe the Environmental Protection Agency is putting, you know, restrictions, and they are not going to allow us to be at 11.7%. So I'm going to go to my mechanical people in charge of the machinery or whatever and say, look, you need to fix this so that you do not have more than 2% over the limit. So that would mean this is your part that would be over the limit. So I don't want this little yellow section to be bigger than 2%. So, the manager of that team might say, okay, well, I'm just going to shift this normal curve down, and I'm going to shift it so that the mean is no longer at 75. I'm going to shift it down, put the mean at 71.37, and then that will do it. And that will make it so that only 2% are over the limit. Okay, then I'll go to him and I'll say, no, this mean is not acceptable. No, I still want a mean of 75. So you're going to have to figure this out. I want the mean to stay at 75, but I still only want 2% above the limit. So what's the manager going to have to do, or whatever the engineer going to have to do? Make it so that what? You're going to have to make it so standard deviation is smaller. You're being more accurate. Your data is clustered more closely around the mean. It's sucked in. It's more consistent. So I need to make a smaller standard deviation. So therefore, he designs it so that it has a 2.4 ppm standard deviation as opposed to the 4.2. So see, he had to reduce that standard deviation in the design of the machine. All right. So the things you would say about this is that it's more consistently around the mean, that less will exceed. You may have said less varied. All of those kinds of phrases would be acceptable as an answer. All right. Last one. This is actually the first concept we learned about normal curve. Please make sure you include your z-score information, your context information, and your percentages in your drawings. And then the rest of it was kind of just straight up regular things there, so I'm just going to scroll down and let you look at those answers. The other day, we did the quartiles, so there's your IQR from a couple days ago. There you go. So that is your review. Any questions on those last ones that we had done? Okay.